Welcome, everyone. Our next speaker is Mr. Scott Dennis. Scott serves as the branch chief for the Aviation Integration Branch for the Army's Development Command Aviation Missile Center, Software Simulation Systems Engineering and Integration, or S3I. And he is also serving as the chief technical architect within the MOSA Transformation Office in support for the Army's Program Executive Office. As a chief for the Aviation Integration Branch, Scott leads a team of 108 individuals, executing 12 projects and operating 8 system integration laboratories within those domains of avionics, supporting Army manned aviation. And as a PEO Aviation chief technical architect, Scott establishes the technical vision, and he is working for the Modular Open Systems Approach and involving a lot of model-based systems engineering and ACVIP as part of that. Scott received his electrical engineering degree at Auburn University in 1992 and has several years of experience with the government. So his keynote speech today will be about PEO aviation, MOSA transformation, and the role ACVIP performs within that. So Scott Dennis, you can come aboard, and we look forward to hearing your message.
Hey, thank you, Alex. It's a pleasure to be in front of such a group today. In my 32 years of supporting Army aviation, I have worked particularly under the aviation science and technology community. I have worked with around AADL back when Meta H, and when the A in AADL stood for avionics. So it's very exciting to be here today, and the maturity and the adoption of AADL and the use of the architecture-centric virtual integration process by Army Aviation, and give you an update of where the Army and subsequently PEO Aviation as part of the Army is moving in the use of AADL and ACVIP. The Army is undergoing 2 very large transformations concurrently. One of them is a transformation to use modular open systems approaches to specify, acquire, develop, field, and sustain open systems utilizing model-based systems engineering, and that's the tie-in to the other transformation activity that the Army and subsequently PEO Aviation is undertaking. And that is the transformation of utilizing digital engineering, the MOSA transformation and the digital engineering transformation are linked. There's a relationship, but they're separate. I can speak authoritatively on the MOSA transformation, but I am going to touch on how AADL and ACVIP also relate to the digital engineering transformation that PEO is undertaking. Okay. Let me bring my charts up here. I've got 7 charts. I've been allocated 45 minutes. I'm planning to leave at least 15 minutes for questions. There is a moderator who's going to assist me with the time and the questions. Let's see. And I am not seeing the ability to share my screen, Alex, on the current options.
You should see share screen at the bottom of your screen. It's the rectangular green box.
There we go. There we go. All I do is I ask you.
Every one of these are different.
Absolutely. There we go. Okay, so now you should be able to see my screen with my opening slide titled ACVIP Industry Day. I performed the introduction, so we're going to go to the second chart. Hey, let me just rapidly, kind of onboard you into the Program Executive Aviation, multi-billion-dollar a year activity where we're developing, acquiring, fielding, sustaining the aviation weapon systems and assets, Apaches, Blackhawks, Chinooks, Gray Eagles, ARLE, EMARS, and it's also simply say we've got a manned fixed wing, we've got a manned rotary wing, and we have unmanned systems that we field in support of the ground Army commanders. So it's very large breadth, very large portfolio, as I said, billions of dollars, and we're kind of categorized into two categories. We've got the enduring force, what we fielded and are acquiring now, and what we're in the process of acquiring, which we call future force, that future tactical UAS, future armed reconnaissance aircraft, Flora, Hades on the fixed wing side. So we've got a collection of enduring force and future force. This inflection point of the Army PEO Aviation embarking on acquiring these future weapon systems gives us a unique opportunity to harness the new capabilities that will be part of this future force and use them to modernize our enduring force. That alone is what's driving PEO Aviation to implement a modular open systems approach to acquiring and sustaining these open systems. But I must mention that it is now statutory. You can go into the law of the land. Title 10 is what covers the armed forces, and you will see MOSA, and you'll see the words major system component codified in the law of the land. So we got statutory requirements, and we've just got this unique point in time where we have this influx of future force that we're going to take advantage of and utilize a modular open systems approach to acquire capability at a more granular level of modularity and apply that capability to our enduring force as we keep that enduring force modularized. Our approach, a PEO Aviation approach to accomplishing this modular open systems approach mission is we formed 9 lines of effort. Some of this, you'll see on the left-hand side, a lot of this you'll recognize, standards, definitely part of one of the key tenets of a modular open systems approach. Everyone, our culture, our industrial base, very familiar with standards. The Army Aviation is familiar with standards, but there's also that part called enabling environment. So we've stood up an architecture collaboration working group that will be currently supporting, its charter to support the future vertical lift. In the next 30 days, it will transition to supporting PEO. We also have an interface control working group that's focused on the unmanned side. This is part of our enabling environment that allows us to collaborate with industry at very, very, very quick speeds. We don't, with these working groups, we're able to collaborate and share data with industry without a contract, award of a contract, public release, CRADAs. It's a very key part of our enabling environment. I talked about standards. I talk about the enabling environment. We're also working on the contracting as part of our enabling environment. We're going to, as we specify our capabilities that we're acquiring at a lower level of granularity, we need the contracts in place to support that approach. So we're working and established a line of effort for contracting. We're also working with our Material Release Authority and our Airworthiness Authority on modifying our processes to take advantage of this, granular level of modular acquiring capability. But the part that's new, and the part from a MOSA perspective, where AADL and ACVIP are going to play a major role, is how do we specify the modularity? We need to to have an authoritative source of weapon system capability and the functions needed to meet those weapon system capabilities, as well as the data that those functions produce and consume. That's kind of the wild, wild west. We're just on the forefront of doing that in some of our programs, to specifying that modularity and make sure that those modules are severable when we determine we need them to be severable, and they're using open interfaces. And MOSA, as part of MOSA transformation, that ACVIP is going to assist us. Many of you have, been supporting Army aviation. We know how this works. We've got a capability on one weapon system that it's just what the user needs, and we want to reuse that capability on a second weapon system. We're going to need the ability to enter into a conversation with that second weapon system prime, to discuss, performance, safety, interoperability with the second weapon system. And AADL and ACVIP, I see, is critical to allowing the Army to collect that information needed to have a very robust and diligent conversation with that second weapon system prime that's armed with some factual data. I'm going to give you some examples in some following charts, but that's where I see AADL and ACVIP playing a very critical role as part of the MOSA transformation approach within PEO Aviation. I'm gonna briefly touch about how ACVIP is also part of the PEO Aviation's digital engineering transformation. But from a MOSA perspective, ACVIP is going to be a key tool that gives us the data and the knowledge to be armed and have a conversation with that second weapon system PM. Because going in to a conversation with that second weapon system PM, when we're trying to reuse that capability, there's always business reasons why that there's multiple reasons why that second weapon system PM is going to come to the table, not wanting possibly to reuse that capability the Army's made an investment in. And ACVIP's going to give us some technical, rigorous data that's repeatable to allow us to successfully negotiate with that second weapon system PM. As part of our transformation, right now the way Congress charters and resources our weapon systems to be specified and acquired and fielded, they're kind of like silos of excellence, within attack, within utility and cargo. But with this transformation to MOSA, we're now taking an enterprise viewpoint. And we've identified some major system components that we have determined that are critical to meeting the PEO's 5 objectives from a fleet of systems using a modular open systems approach. And those major system components now have the PEO Aviation headquarters involved in leading with their subordinate PMs the specification and acquiring of those 11 major system components, which I have listed here in the center. So we're already transforming how we're conducting our business. And now for the first time, the enterprise has looked across current capability and planned future capability, budgeted future capability, and have anointed some major system components to be enterprise level, and thus having enterprise involvement with that subordinate PM who's been identified to specify, acquire, and procure that capability. And so here's an example. I've got 2 examples of how PEO Aviation is transforming to a modular open systems approach. Currently when we go out and procure a weapon system, like a manned rotorcraft weapon system, we use a statement of work, which we use to delineate what we want the humans to do from the supplier side. We use a performance spec to delineate what we want the system to do. And then we use some government furnished equipment, which drives some level of modularity, constrains our suppliers with some level of modularity, and we also provide some GFI. But going forward, right now, we've identified some capability areas that traditionally are weapon system prime or OEM, depending on the specific business model. They have had the authority to take a performance spec and then derive the requirements for that mission computing environment. We are now with some level of maturity encapsulating those requirements, both performance, functional, data, logical architecture requirements, as well as the statement of work, and then providing that to our subordinate PMs that are acquiring systems that utilize a mission computing environment. And so I see that AADL and ACVIP is going to be very critical as we acquire configuration items as a result of these, what we technically call component specification models for AMCE, to document the performance of the CSCIs on different computing environments using different technologies as interfaces, as we go and strategically determine where we want our investments to be reused across multiple weapon systems. At this point in time, I kind of want to do a check within the audience if I'm using words that resonate with the audience and specifically how AADL and ACVIP are going to be used to arm PEO Aviation on the government side with that needed data to have a very intelligent discussion when it comes to reusing capability that we've already procured on multiple weapon systems.
Yeah, Scott. So I will tell the audience now. You have a Q&A capability, question and answer capability. Please post any comments or questions there, and we will try to field those questions.
Okay, but just a course correction. Am I using words that the audience recognizes? I need a member of the audience to verify either I am or not, and I'll try to use different words. Yes, Ms. Burns, over.
Sorry, I was just going to say yes, you're using words that resonate.
Excellent. Excellent. So I'll move to the second example. And I was very strategic in giving this example. The aviation mission computing environment and us specifying that this, at this level of granularity, this modularity is very key to enabling software reuse. We currently haven't really achieved the maximum benefit of capability instantiated in a computer software configuration item, and this approach is a critical step. There are other critical steps that have already been addressed, but this is the next critical step to allowing PEO Aviation to execute software reuse across many uniquely designed and developed computing environments. The second one is just as strategic. And I'm going to talk about why I'm bringing you the second one. So I talked about how PEO Aviation now, transforming to a modular open systems approach, has identified enterprise level major system components within its portfolio that are key to meeting its 5 objectives that General Barry, the PEO of Aviation, has, encoded, instantiated as what he wants to, the benefits he wants and expected to receive from a fleet of systems using a modular open systems approach. Well, the Army as an enterprise, so PEO Aviation is a subordinate organization within the Army, The Army as an enterprise has made a similar modular open systems approach decision on modularity, and that is the CMOS form factor. So it's an acronym within an acronym. CMOS is the collection of modular open suite of standards, and the CMOS form factor is kind of the hardware equivalent of utilizing for fielding, utilizing the CMOS, those collection of open standards that our ground brethren in the Army have developed. And the CMOS form factor is an Army enterprise. So as a subordinate organization within the Army, we're constrained to receive it and tailor it and execute it. We are in the process working with our ground colleagues in the Program Executive Office C3T and the DEVCOM C5SIR Development Command, a sister command to the Aviation and Missile Center, on adding the additional requirements needed for Army aviation. And so we're moving from getting capability that we currently field in its own LRU, line replaceable unit. Think of, I'll just say box, to getting that capability in a card. Our industry has evolved, the technology has evolved to now afford us the opportunity to get these capabilities where previously we had to get them in their own enclosure. Now industry is affording us with the technology evolution to getting these capabilities in a card. But as such, we are making some modularity decisions. We're identifying key interfaces within those modules, and key interfaces, that's a reserved term. If an interface is identified as key, then A, it must be open. B, there must be some level of conformance performed against it, because the acquirer has determined that interface connecting to those modules is key to meeting their technical and business objectives. So we are working with our ground colleagues on how to take the Army's enterprise modularity decision of utilizing the CMOS form factor and applying it to Army aviation. Again, so now we're going to have suppliers providing cards that are going to fit into an enclosure in a backplane. I see AADL and ACVIP as critical, allowing the Army PEO Aviation to collect the needed engineering data to enter into an intelligent discussion with our suppliers, our primes, on the performance, safety, airworthiness, cyber footprinting of these capabilities. So that was the second example that I brought. Now I'm going to talk about how ACVIP, AADL, and ACVIP are part of, and I can't speak, I can't really answer many questions in this area, as part of the Army's digital engineering transformation, and subsequently PEO Aviation's digital engineering transformation here coming up in a few slides. But part of my role in the director of the MOSA Transformation Office, Matt Sipes' role, is we've got a myriad of standards, and some of them are overlapping, and our industry suppliers, they just need the Army to guide them on how to use these standards, and when how the Army is expecting to use them. And that's the role that I'm in, supporting and using reference architectures and product architectures, enterprise product architectures, to help guide our supplier base with wading through the myriad of standards. Our supplier base is very good at building what we ask them to build. But it's not very intelligent just to list a collection of standards. We need to assist industry with how we're expecting these standards to be implemented and how to resolve where there's overlap. And I made a slight modification to the slide to show, and it's kind of hard because it's a different viewpoint with AADL, but show where the AADL standard fits, on that system analysis and on the design axis. Was my best attempt. And I can't see the Q&A, Alex, so I'm going to depend on you if there's any questions that come up to verbally point me to them.
Yeah, so far I don't see anything. So audience, if you've got questions for Scott, anytime that you post those, I will try to relay those to Scott to answer, or I'll try to answer myself.
Okay, hey, this is I never I never get through a presentation with so little questions. I feel I'm not connecting or communicating here. So here is my wrap-up slide where I talk about in my abilities to talk about how AADL and ACVIP are part of the PEO Aviation's digital transformation effort. That's led by another organization within PEO. But there is a relationship between the PEO Aviation MOSA transformation activities and the PEO Aviation digital engineering transformation activities. So AADL and ACVIP are part of PEO Aviation's digital engineering transformation. I can only briefly talk about any specific questions I'll have to take and pass back to APO Engineering, being led by Lars Eriksson, for intelligent answering. But we are investing resources in training people, procuring the tools on AADL and the use of AADL for that architecture, the ability to perform an architecture-centric virtual integration process. In our digital engineering environment, there's also additional tools, and many of you are familiar. We have some translators between face modeling language and the AADL modeling language that I'm aware of, and I was part of resourcing. But SysML, Windchill, and there's a whole activity ongoing with DevSecOps. It's clear to us as we start specifying and procuring capability at a low level of modularity. PDFs, Excel files are not enough. These are very, very complex weapon systems, software intensive weapon systems. And AADL, unlike SysML, gives us the ability to rigorously, deterministically, analyze performance. And the architecture-centric virtual integration process allows us to look at, these different elements working within a system, data over a specific bus using a specific technology, loaded at a certain rate with the CPU. It's just absolutely critical to acquiring and fielding complex software-intensive weapon systems, as well as, arming PEO Aviation to enter into that intelligent discussion with that second weapon system prime on the reuse of these modules in terms of safety, airworthiness, performance, interoperability, and cyber resiliency.
Hey, Scott, I do have a question that came up from David. I don't know if I'm pronouncing your name correct, but he asked, are you targeting DoD DevSecOps reference design? Can you talk to that? I can talk a little bit about that.
Yeah, I work around that team. Design would be, my words would be relative to design, it's a very narrow field of view. Design related to capability instantiated by software. And what I have seen currently is we're taking an incremental approach. And what I've seen is our incremental approach is focusing on software that's hosted on, you know, a Windows OS or a Linux OS environment. I haven't, you know, seen the actual activities under DevSecOps that are addressing, you know, real-time safety critical embedded systems. So that's my answer to design.
You know, we will be presenting aspects in our presentation on DevSecOps and Agile. We believe that ACVIP does support that. And we have been interacting with Ms. Carmela Ross of PEO Aviation, who's leading up that effort for DevSecOps. And we do believe that the real-time embedded system aspect needs to be addressed on that.
Absolutely, as do I. And I can tell you at the conclusion of this call, I'm going to go back to work a task to update the PEO Aviation MOSA implementation policy memorandum. And where I am on that task is the section that addresses software. I want to clearly delineate from the previous policy that was published. I want to clearly delineate the DevSecOps from the work that's ongoing within PEO that's addressing, you know, real-time safety critical embedded systems. Because there's a lot of work, and many of you are part of that work that's ongoing. A lot of it is instantiated in the FBL architecture framework version 4. Some of it's instantiated in the work that the Army is doing within the FACE consortium and the SOSA consortium and the VITA consortium as it relates to hardware anyways. So there's a lot of activity that we're undergoing as part of the MOSA transformation that is related to real-time safety critical embedded systems on the software side. So I want to clearly delineate that in a policy memo for the next rev anyways.
Scott, we got 2 more questions that have popped up. Reed Little says, seems that PEO Aviation must be the driver for acquisition of reusable software pieces. What are they doing about that?
Yeah, so that's definitely the vision. Hey, but I want to be clear that within the Army, there's already, I'll say TRL level 9, technical readiness level 9. We are doing software reuse, particularly on the ground community. But that software is running on a computing environment that uses Linux and Windows. And we're utilizing that, and we're utilizing that where we can. But as you know, our weapon systems have functions that have been determined to be safety critical, and some of the majority of our computing environments I would categorize as safe, secure, real-time, safety critical embedded systems. We're on the tip of the spear for laying the foundation to allow us to acquire capability instantiated in software hosted on a safe, secure, real-time, safety critical environment. We're actively doing work against that vision. So did I answer the question fully? Over.
Reed Little came back and he said, could the name of the program already reusing software be shared?
Well, so right now today, software reuse, we could spend an hour talking about the levels of software reuse, from requirements to source code to object code to binary. There are 2 different activities where software reuse is ongoing on a real-time, secure, safety critical embedded systems. That's with the Harris's flight scene digital map, where we are reusing source code, in some cases object code, but the weapon systems as they're fielded have unique software layered architectures and mission system designs that require, the prime of those weapon systems to tailor how that software is integrated and utilized. The other example, it's kind of cheating because they're really libraries. There is a line replaceable unit that's reused on all manned rotorcraft weapon systems, the improved data modem. There are libraries that the supplier develops. There are two variants. There's I think a C++ and an AADL software libraries that are provided as GFE to the weapon system primes that they utilize to interoperate with that line replaceable unit. So that's more at the object level where they link in those libraries. But those are very low level libraries. I wouldn't call them, and I'll use a future airborne capability environment, a technical standard term to talk from, because it's not proprietary. It wouldn't be software allocated to the phase portable component segment. Those are very low level libraries. Those are the two best examples. I can tell you we are doing work to look at reusing capability instantiated in software that allows us to, field intelligent teaming and cognitive decision aiding. But there's some more foundational work that we have to do with functional architecture work and logical architecture work and data architecture work. But we are doing that. So there's some very strategic capability instantiated in software on real-time safety critical computing environments that we're focusing on for reuse across multiple weapon systems, particularly as we field these, future force systems to be able to reuse them on our enduring force to keep them modernized.
And Scott, I'd like to add to that, the future airborne capability environment FACE and the host hardware open system technologies, those are enablers, we believe, for reuse. We do have the whole MOSA, Modular Open Systems Approach, as Scott said, was mandated. And on the new programs for future vertical lift, we have open systems verification that's going on to test those things out. And the ACVIP is part of that effort there too. So just wanted to add that. We have another question. Oh, go ahead, Scott. Didn't mean to cut you off.
I was going to say, and I can see some of the names, and I see Miss Burns and and Alex, but I want to say this is hard. This is hard. Most of my colleagues and senior leaders, it's hard to communicate to them. They have an expectation if they bought a capability instantiated in software and they have the rights to the source code, that's all they need, and it's reusable. And many of us know, Miss Burns and Alex, and there's others I could probably name if I could see everyone's name, that opportunistic reuse, trying to reuse a capability after it was acquired, and then determine that you wanted to reuse it. It just looking at the history, the previous precedents, it has a very low probability of success. You have to strategically determine that capability is going to be reusable up front, and how you specify it and how you acquire it, and the additional elements needed when you acquire it, the test harnesses, the test plans. It's hard. It's hard. I spend a lot of time having to go look at existing software that was procured without any intent to be reused, but the Army may have the data rights to the source code, and having to do experiments and demonstrations on attempting to reuse it and explaining why it would probably be more efficient for a second supplier, another supplier, just to redo it. That's still a barrier within the community that I have to work with, mostly on the government side. The supplier, the industrial base, I think, knows that. I'm still working, and I haven't been successful to educate my colleagues and senior decision makers. Data rights, definitely critical. You got to have the data rights, if you know, whether that's a licensing or the source code. But that's just one of many critical steps that you must do if it's the intent to reuse a capability, especially instantiated in software where it doesn't come wrapped with its own processing resources. So thank you. I wanted to just to share that.
Yeah, data rights is much of a challenge.
It is.
As anything, but in
I
most
spend more time than I want to say, you know, explaining that and having to explain it by doing, because I'm tasked to do it.
Right. We have another question from Weber Massengale. Yeah, another question from Weber Massengale from Bell. He says or asks, is PEO Aviation working on building a plug-in translator to link Windchill and SysML? It's something we've looked at for reliability and maintainability analysis within SysML, but it doesn't seem like the existing capability linking the two was too sophisticated based on what he saw. That might be a question better answered by the folks that are doing the implementation of the digital engineering environment. But Scott, do you have any insight into that?
I don't. I took that as an action to bring back to the organization responsible for the digital engineering transformation within PEO. I will say that translation must exist, because we are definitely using SysML as a way to specify some of the functionality that our the modularity that we've determined, that those modules, you know, we're expecting the functionality for them to perform. So I would expect someone is working that, but I'll have to take that as an action.
Yeah, we're typically using SysML as the source of truth, and then taking that information and translating down to the other, such as AADL, to do the lower level type analysis. But yeah, we'll have to look into that further with respect to the Windchill and the tie-in to SysML, in particular the SysML that we're using as Cameo Architect within the Army. Any other questions? And Weber, does that answer your question? Okay, we'll get back with you on that.
Yeah, well, I took that as an action, and I'll coordinate the response with Alex, so he can broadcast that response back to the individuals here. So, you know, and kind of in closing, again, it's been quite a journey. As I said, I've been working around projects and people. You know, back when you know Meta H, and you know the first A in AADL was avionics. I actually hired a civilian who, part of his master's degree, actually had taken in AADL courses, and is a member of the team here. So we are maturing. I think many of you probably aren't happy with the speed of, you know, PEO Aviation adopting AADL and ACVIP, but it's happening. It's in requirements. The use of AADL, the use of ACVIP are contractually required in some of our acquisitions that we have on the street now. So just be patient. You know, the Army's a big apparatus, and be patient, but it is slowly being adopted, because we realize we've got to do something different. Especially for these very, very complex, safety critical, software intensive systems. We've realized as we're transitioning to model-based systems engineering, SysML just doesn't give us that rigor, that repeatability, determinism, and we feel ADL provides that capability where SysML, especially with the use of diagrams, falls short.
Thank you, Scott, for the presentation and answering the questions. If anyone has further questions for Scott, please, you can post those in the chat. We'll try to get back with you later.
Okay, sounds good. Thank you very much. Again, it was so excited to have this opportunity to be in front of, the people on the ground, working on the ADL standard and the use of ACVIP, the handbooks, and then I recognize some of these names are actually applying it on Army systems, PEO Aviation systems. So it's very, very exciting, very exciting.
Yep.
I wish you all, thank you for your time, and I wish you all have a great day.